Today you'll learn how to write unit tests in Python using a module called Pytest. Now this is a fantastic skill to learn. It's definitely something that you need to know if you write code in Python, and fortunately it's relatively simple, and I'll walk you through all of it in this video. So with that said, let's go ahead and get started. Now quickly, let's just have a look at Pytest, which is the module we're going to be using. Now there's multiple ways to write tests in Python, and there is actually something built into Python called unit test. Now this works, you can use it, but it's a little bit less intuitive and the syntax is a bit more challenging than this module right here. So I'm going to show you how to use Pytest. It's very easy to set up and install, but again, you can use pretty much anything that you want, and the testing principles I talk about here will apply across various different testing frameworks. So with that in mind, let's get Pytest set up, and then I'll talk to you about the purpose of a unit test, why we write them, and I'll show you a bunch of different examples. Okay, so I'm going to go to Visual Studio Code, but you can work in any code editor that you want for this video, and I'm going to assume that of course you have Python installed. Now since we're going to be using Pytest, what I need to do is install the Pytest module. So to do that, you can just open up a terminal or a command prompt depending on your operating system, and you can simply type the following command, which is pip install Pytest. Now, if you're on Mac or Linux, you can do pip3 install Pytest, and that should install it for you. So I'm going to go ahead and run the command. All right, so that was installed successfully, but we're also going to install one more module called pytest-mock. Okay, so same thing, pip install Pytest mock or pip3 install Pytest mock, and we're going to use this for mocking different files, functions, you'll see in 1 second, but just install it so that we have it for later in the video. Okay, so everything is installed now, and I want to quickly show you how we run a test using Pytest. Now notice that what I've done here in VS Code is I've opened up a directory. This directory is called Python testing. The way I did that, let me just get out of here. So I went to File, I went to Open Folder, and then I just made a new folder and I opened it up. Okay, so you can follow those same steps if you're working in VS Code or whatever other editor you want. Then what I can do inside of VS Code is I can make a file. So let's say I have some file called main.py, and this contains some code that I actually want to test. So maybe I have some function like, I don't know, get weather or something, and it's going to take in maybe a temp, and we can say if the temp is greater than 20, then return hot, otherwise return cold. Okay, so something that we might reasonably want to test to make sure that it's working. Now that I have this file, what I would do is I make another file, and this is the file that will contain our testing code. Now for that file, you're going to name it test underscore and then the name of the module you want to test. So typically we're testing one Python file at a time. You can also test individual functions and all that stuff that you'll see, but usually you have one test file associated for every file or module that you want to test. So I'm going to say test underscore main.py, and again I'm prefixing this with test, which is important because that's what Pytest is going to look for. So main.py contains my code. I then have my test underscore main.py, and this is where I'm going to write my testing logic. Now inside of here, literally all I need to do in order to initialize a test is I need to import the code that I want to test, and then I need to write a function that contains an assertion. You'll see what I mean, but I'm going to say from main import and then get weather. Okay, so that's the function that we wrote inside of main.py. And then I'm going to write a simple function, and again I'm going to call this test underscore, and then we'll go with get weather. Then what we can do is we can say the following. We can say assert and then get underscore weather, and we can pass this with maybe something like 21, and we're going to say that this is equal to and then hot. Okay, ignore all of the auto completions that are popping up. This is what I want you to focus on. So we just wrote test get weather. Okay, we then call the get weather function. The get weather function, we give 21 as a value. We would then get the return value here and just assert that it's equal to hot. An assertion simply is going to tell us if something is true or false. So we're saying assert and then some condition. This condition needs to be either true or false. If the condition is true, it means our test case passes. If it's false, it means the test case fails. So now that we have these scripts, let me show you how we would run the test. To do this, we simply go to the directory where our Python code is from our terminal. In this case, it's inside of Python testing. And then we type pytest, not Python, pytest. And then the name of our test script, which is main.py. So test underscore main.py. Hit enter, and you can see that it says that it looked in this directory and that we had one test case that passed in this amount of time. Okay. Now I'm going to show you what happens if this were to fail. So maybe we check if this is equal to cold. Then what I can do now is save and run my code. And you see that it tells me that I got an assertion error and that we actually failed the test case. So it says test main.py at this function, test get weather. There was an assertion error where hot was equal to cold, and it tells me exactly what the changes were here and that this assertion failed. Okay, that's it. That's literally all you need to do to write a test, and you can have multiple of these assert statements. So assert, get weather, etc., something like this. Okay, and you can see if these work. Okay, so those are the absolute basics. That's how you create a simple test, how you import the code, and how you actually run it using Pytest. Now I want to quickly talk about what a unit test actually is and why you should write it, but first, a quick message from our sponsor. Now, speaking of testing, this is something that's of critical importance to pretty much all organizations. There's actually entire roles focused just on this, testing. For example, you have QAs or quality assurance engineers whose entire job is to focus on testing software. Now, if you are someone who's looking to break into tech, you might think that you need a ton of experience, but that's actually not the case. Software QA engineering is one of the easiest roles to get into to start a high-paying tech career. And Careerist, the sponsor of today's video, makes this even easier. As a QA engineer, you'll play a crucial role in software testing, ensuring the quality of the products that we use every single day. Now, with Careerist Online QA Bootcamp, you can land a tech job in as little as 7 weeks. No coding, no tech background required, and the best part, it starts at just $690, making it one of the most affordable ways to invest in your future and to break into tech. Now, there's been over 1,000 graduates already that have landed jobs in 42 states, working remotely and earning salaries of up to $113,000. Plus, Careerist provides expert mentorship, hands-on training, and career coaching to set you up for success. So if you've been looking for a way into tech, this just might be it, and you can see all of the details from the link in the description. A massive thank you to Careerist for sponsoring this video, and now let's get back to the tutorial. So jumping back into it, I quickly want to discuss what a unit test actually is and the importance of doing so. Now, you already saw an example of one just a second ago when we were testing a function, but there's all different types of tests that you can perform. A unit test is the smallest type of test, and it's typically testing one very small component of code, something like a function or a method, potentially a class as well, but typically it's limited to things like functions. Now, the point of a unit test is to ensure that you get the expected outcome or result from a small unit of code. This way, if you do get an error when you're in a larger development environment, you know exactly where it is, and it's isolated to one specific function or component that you can then go and fix. So the reason why we write unit tests is to cover a majority of the code and to ensure that all of the small components are working as they should be, so that if we do get an error, we can isolate where it comes from and fix it very easily. Now, there's all kinds of other tests that you can write, for example, integration tests, system tests, end-to-end tests, and those have different purposes, but a unit test is focused on a small unit of code, something like a function, and ensuring that at least these small components are working properly so that we can isolate the error and ensure that at least the smaller components of the code are all functioning correctly. It's also useful to have these tests when you're doing development because oftentimes you can break things that you don't intend to, and by having good coverage of multiple functions and areas of the code base, you can very easily see where something went wrong and go and fix it, especially if you write the test correctly. In fact, there's actually a whole kind of stream of software development called test-driven development, which means that you write tests before you write code. So that way, while you're writing the code, you can run the test against it and you can make sure that it's working properly, and you're writing your code to satisfy certain test cases to make sure that it passes rather than writing the test cases to fit the code that you have. So it's kind of like defining the requirements beforehand and then coming up with the solution that kind of satisfies those requirements. And if you've ever done something like a leak code question before, this is kind of exactly what you're doing. The test cases are already written and you're now writing a solution and you're trying to pass all of those tests. So hopefully that gives you a little bit of information, but now I want to dive back in and show you some more practical examples. Okay, so on my screen here, I have this file main.py. Now, I know these functions are very basic. We're going to start basic and get more complicated. Now, you can see here we have a simple add function, which adds two values together, and then a divide function, which divides values and also raises a value error if you try to divide by 0. Okay? Now, if we want to test these two functions, we can do that by writing this test main.py file. Now what I did here is I imported main, and I imported add and divide. I then imported Pytest because we use that later on, and I wrote a few different assertions. Now inside of test add, this is the function for testing my add function, right? And I test the add function 3 times with 3 different inputs. Now, when you test your functions and you write a unit test, you usually want to make sure that you're covering as many things as possible. So various edge cases that could pop up, empty inputs, weird errors, strange things, right? You don't just want to test what you might expect to be passed. You want to test with all different types of inputs or things that we call edge cases to make sure that the function is robust and it works in all different scenarios. Now, obviously, we have a basic example here, so it's kind of hard to do that, but you can see that we test 3 different inputs here, right? So 2, 3, -1, 1, 0, 0, and then we actually write a description as well for what this test is doing. This is optional, you don't need to write the description, but you're able to just specify after the assertion what this test actually was for, so you can see more details on if it does fail. Now what I've also done here is I've showed you how to run a second test, this one for the divide function, and inside of here what we're doing is we're actually testing to make sure it raises an error. So this is another thing you would typically want to test. If there is something like a value error that's raised, you would want to test to ensure that does actually get raised or handled, and that's what we're doing here. We're saying with pytest.raises, then we specify the value error or the exception that we're expecting, and we're matching a specific error string. So in this case, I'm only going to kind of catch this here if we raise the exact value error that contains cannot divide by 0. Okay, so if I go now to run this code, I just need to change into the correct directory because I put this in a basic folder. I can run pytest and then test main.py, and you'll see that it says 2 tests passed in 0.01 seconds. Now, if I change this to maybe, can divide by 0 or something, change the match text, and I run this here, you see now that we get an error, and it says, hey, we didn't match this, right? So the regular expression can divide by 0 did not match with cannot divide by 0, so it gave us the assertion error, and it told us exactly what the problem was and where it occurred. Okay, now if we have multiple failures, so for example, we make this like 1 or something, 0 or 0, 0 for the add function, and run this, you can see now that it says 0 plus 0 should be 0. This is the one that failed. And then same thing, regular pattern did not match. Okay, so it tells us where the errors are in the multiple different test cases, and then we can go up here and we can see exactly where they occurred. Okay, so let's go back and let's make these work. And now I want to show you some more advanced things that we can do here with testing. All right, so I have another example here now that's using a class. So notice we have our user manager, we have some initialization, we add a user, and then we're not going to allow you to add a duplicate user. Okay, that's pretty much all that we want to test here. We want to make sure that functionality works properly. So if I go to my test main.py, you can see that I've set up 2 different tests here. One just testing to make sure that we are able to add a user, and one testing for the add of a duplicate user. Now, something worth noting is that anytime you're testing different logic or functionality, you'll want to do that inside of a new test or a new function. So because these are 2 different things, like the ability to add a user and then testing if a duplicate user gets added, we want to make these 2 separate functions so they run as independent tests. You don't want to test too many things in one place. You want to isolate it to one specific type of thing that you're testing so that it's easier for you to understand when something did break. And again, you're only testing in kind of one place. Hopefully that makes sense. Now, what I want to show you here is something known as a fixture. Now, a fixture is something that you can have run before every single test. So it's kind of like a setup step, and it will just run and give you usually a fresh instance or some fresh data. That's one thing that you can do with it before every test runs. So in this case, we've defined a Pytest fixture, and what this does is create a fresh instance of the user manager before each test. We've then kind of injected this fixture inside of our functions here. So we've said user manager, which is the name of this function, which is a fixture. And every time these tests run, it's going to run this function and then give us a new user manager. Now, the reason why this is important is we want to make sure that for each test, we're starting with a fresh instance of this class, and we're not using the same class multiple times. If I were to use the same class multiple times, then the effect of one test could affect my other test, and we typically don't want that. We want our tests to run in isolation and on kind of the same environment, not something that could be dynamically changing based on the order in which tests are running. So again, all this does is give us a new user manager instance every time the test runs. So this test runs because we've injected this user manager dependency. It runs this function and then gives us the user manager. And then this test runs and it will give us a new user manager afterwards. So let me just show you running this and then we can look at this in more detail. So I'm going to say Pytest testmain.py, and you can see here that it ran and 2 tests passed. Now, I want to show you what happens if we remove this fixture. So let's say I were to comment this out, and rather than having user manager here, I'm just going to specify a global variable. So I'll say user manager is equal to user manager like this. Okay, so now I've created a new user manager, and this is a global instance, and I just create it one time, not inside of this fixture. So now watch what will happen when I run my tests. You notice that we actually get a fail. So our second test, when we test for the duplicate user, fails. And the reason why it fails is because this first test added this John Doe user, and then we didn't clear the user manager. So for the second test, when we tried to add this user here, it gave us the fail at this point because there was already a user inside of the user manager class. So that's why we need this fixture, which is again that kind of setup operation that runs before every single test. So we clear the user. Of course, you could do this manually as well, but this is kind of a nice thing that's built into Pytest. So let me show you another example of when we might want to do this. So moving on to another quick example here, and you can see that I have a database. Now this is just simulating a basic user database. In this case, I'm just doing it in memory, but this could be a real database that works with something like SQLite or Postgres or MongoDB. And in the case of a database, you want to be careful how you use these in testing, and obviously ensure that you're clearing the database in between different runs so you don't get errors similar to what we had happening before. So here we have 3 operations we'd want to test: adding a user, getting a user, and deleting a user. And maybe we would actually want to test adding the user multiple times, one to just make sure it adds properly, and another time to make sure that we can't add an existing user. Okay? So if I go to my test database file, you can see that I've written a fixture. And this time for the fixture, what I've done is I've used this yield keyword. Now what this is going to do here is it's going to yield the database when it needs to be used, and then as soon as the test has finished, it's going to run any code that comes after the yield keyword. So anything before or at yield will run before the test, kind of as a setup operation, and anything after yield will run as a teardown step or a cleanup step after every test. So for example, if this was a real database, we might need to actually clear the database, or we might need to do something like remove the file, set up a new connection, whatever. There's all kinds of things that we might actually need to do to tear this down. So that's what I'm showing you here with this fixture. Set up by creating a new database instance, yield the database, and then when we're done, clear the database. Okay? And then you can see here that I write 3 tests. So test add user, test add duplicate user, and test delete user. And then if I come here, let me go to Pytest, and then what is this one called? testdb.py. And you can see that all of this worked, and my 3 tests passed in this amount of time. Okay, just showing you one more use case here of the fixture with that teardown operation. So now let's look at a new feature which is quite useful but difficult to pronounce, and that is parameterized testing. Now let's say we have some function like this, isPrime, where we want to check if a number is a prime number. This is clearly something that we would want to test because we want to make sure that this works properly, and you may actually even want to write this test before you start writing the function. Regardless, the way that you can set this up so you don't write a ton of duplicated code is to have something like this. So what we can do is we can import Pytest, and we can use this decorator, pytest.mark.parameterize. We can specify what it is that we're actually passing here for the parameterization, and in this case we have num and expected. Now what this is doing is allowing us to create a list of a bunch of different inputs and potentially the expected output that we want to pass to this function to make it more dynamic and less repetitive. So rather than having to constantly write, assert is prime and then pass like 7 and then, say this is equal to true, and then do that for every single one of these values, what we can do is we can have these values get passed in as parameters by using this parameterize, and then just have this code ran for every single one of those parameters. I hope that makes a little bit of sense, but what's happening is we're specifying, okay, num and expected. Notice that matches up here with num and expected. And then we have the number, and then we have the expected value in the tuple. Then this test will run for every single one of these cases that we're passing to it, so that we can just write them all here and then just do the same repetitive code over and over and over and over again inside of the function like it's designed to be used. So now if I come here, let me go and say Pytest and then test_main.py. And you can see that it runs this and all of these passed. And then let's make one of them fail by just changing the test case to be false here. And you can see that now it says it failed, and it says 1 failed, 7 passed, and it tells me which test case failed. So this is a much better way to do it when you're going to be writing a lot of tests that are very repetitive and essentially just have different inputs and different outputs. And of course, if you had multiple values like num1, num2, then you could just specify these here and you would just add another parameter. Okay, so you'd have num2 expected, and you can make these as many or as few parameters as you want and change the code to be as dynamic as you see fit. So a very useful thing, definitely remember that and use that for kind of creating multiple tests out of this list of parameters that you might want to use over and over and over again. So now we're getting into something that is quite important and many people really don't understand, and that is mocking or mocks. Now, a lot of times when you write tests, there's part of your code that relies on something that's not active in a testing environment. So for example, we maybe have this front-end code that we're running, and the front-end code relies on a back-end API in order to be working properly. But I don't want to have to spin up the back-end API or set up all of these different dependencies just to test the front-end. So what I would do is I would mock or create a fake version of that dependency, in this case the backend API, that returns some fake data so that I can simply test the front end without worrying about all of these other dependencies. You're going to see exactly what I mean in these examples that I go through, but whenever you have kind of a complex system and you want to write a simple unit test, you want that test to be testing that one thing, that one function, that one part of your user interface, your front end or whatever. You don't want it to be kind of dependent on all of these other variables. For example, you're testing this front end code. Maybe the front end code works fine, but there's an error with your API. You wouldn't want the API to trigger an error in your front end testing code because really there is no error there. It exists somewhere else. So instead, you would mock that component, which I'm going to show you here, so that you know that you're testing just this isolated area, which is what the unit test is meant to do. So here's a great example. I have this function called getWeather. What I want this to do is send a request, a network request, to this API. Now this API is something I don't control. Maybe one day it goes away or it doesn't work anymore, or maybe I need an API key, or maybe it's down. I wouldn't want that to make this test fail because that's not my fault. That's not what I'm trying to test, okay? I'm trying to just test that I wrote this code properly, not that the API is working or not working. So what I'm going to do is I'm going to mock this API so that I simply have it return something automatically without having to actually go and send this request. You'll see what I mean in 1 second. Anyways, this is what the code does. If the status code is 200, we get the JSON. Otherwise, we raise an error. And really, this is the part that we want to check. We want to make sure that if the status code is successful, we get the JSON. Otherwise, we raise our own custom error. So if I go into my testing file, this is what it looks like. We say test getWeather, and we take in a mocker. Now this works because we imported or installed that Pytest mock library. Okay, so you have to call this mocker, and what I can do is I can patch a specific function. So what I've done here is I've said mocker.patch, and I've patched main.request.get. Now this is main, this is requests, and this is .get. Okay, so I'm patching that, and when I patch that, it means that I can essentially kind of fake what it's returning. So I say mock get, which is what I've stored right here, which is my patch. I say the return value and then status code is equal to 200, and the return value .json.return value is equal to this. Now, this might look a little bit complicated, but because JSON is a function, it has access to this return value. So because of that, we specify the return value from that function, which is equal to temperature and condition. Okay, and then we specify again the status code to 200. Then we say our result is equal to getWeather, so we call the function, and then we specify our assertions. So we want to assert the result is equal to temperature 25, condition sunny, and additionally, we can actually check if this mock get was called. So I want to make sure we did actually indeed call this request.get, and that we called it with this parameter. So I'm saying assert called once with, and then this. Now there's all kinds of other functions that you can use here. For example, if you want a function to be called 10 times, you could do that. You could actually write the code to check that. You could make sure a function was not called. And a lot of times what you'll do if you have some kind of like routing code, for example, is you'll test to see if various mocks that you've set up were either called or not called. So you can mock this function, and then later you can make sure that it was called, and it was called with a specific parameter or without a specific parameter, right? There's all kinds of different checks that you can make here. Anyways, I want to show you running this code and that it does actually work. So let me just go into this directory, and I have a few other examples in a second to show you as well. So I'm going to say Pytest and then test_main.py, and you'll see it runs and the test case passed. Okay, so this is how you mock something. Now let's look at another example to make it more clear. So let's go into a mock for a database, which is another thing that you would typically want to mock. Okay, so I have this database and I import SQLite 3. Now what I do is I connect to this user's database, I get a cursor, and then I execute this command and actually insert something into the database, okay? Then I have this test database file. Now what I'm gonna do here is I'm gonna mock the connect function so that we don't actually need to set up the database and connect to it. Okay, so I'm gonna mock the connection so that if, for example, this database is not available in our testing environment, it doesn't cause this code to fail. So I mock this, the connect, and then I say my mock cursor is equal to the mock connection dot return value dot cursor dot return value. Okay, so what the cursor's return value is going to be equal to this. I then say save user Alice 30, so it would call this function, right? We would mock this connection and we would mock the cursor. So now we have those stored in these variables, and then what I'm able to do is assert that this mock connection was actually called with usersDB, so it is performing the connection even though it doesn't actually need to connect to it. And then I'm going to check that my cursor mock was called with .execute and with this, right? Assert called once with insert into users, blah, 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 blah. Okay? Again, I know it's a little bit confusing, but this is how you work with mocks and how you fake the database. So now, if I were to run test database, it's not actually going to create a new database, which it typically would otherwise. It's just going to mock that code and make sure that my logic is correct without relying on that SQLite database to be connected. So if I say pytest test_db.py, you can see that it runs this, it runs very quickly. And if I look here, I don't have any database created because it wasn't necessary to create that. Okay. So now that we've done that, I'm going to show you one more here with kind of a more advanced example. So let me just open this up for you and let's have a look. Okay. So here I have a API client, and what this does is send a request to some specific API. Okay. And then we, get the JSON or return some error. We then have this user service where we specify the API client, and then we have the ability to get some username from the API. Okay, don't worry too much about the exact code, but it's a little bit more advanced with some multiple classes. So what I'm going to do here inside of test service is I want to test this part, this user service, without relying on this API client to actually be functioning properly. So what I'm going to do is I'm going to mock the API client. So if I want to mock an entire class, for example, this is the way that I would do it. Rather than mocking just one function, which is what I showed you how to do previously, or to mock, for example, a method, I want to mock the entire class. So I'm saying my mock API client is equal to mocker.mock, and then the spec that I'm mocking is this class, okay? Then what I do is I now go and I mock the different functions on here and any return values that I want to have. So from my instance here, I say .getUserData, .return value is then equal to this. Then I can say my service is equal to user service, and now I can pass in my mock rather than having to pass in the actual API client object, right? Because if I have to pass in the actual API client, then if the API client doesn't work, then this code won't work and I can't run the test. So instead I pass in my mock, right, which is my fake version of this, where I've now kind of faked the data that's coming from getUserData, which is what this service will rely on. So I'm injecting the mock API client, then I can call the method. This method, I'm not mocking this method, but it's using something that's mocked. I know it's a little bit confusing, but you have to set this up quite often, which is why I'm showing it to you. So if we look at service, you can see that it says self.API client. Now API client getUserData is mocked. So inside of this function itself, it's using one of our mocks, okay, and then returning the data and making it .uppercase, which is what we want to test. So what I'm doing is I'm saying, okay, I want to assert the result is equal to Alice in all uppercases, because we've mocked that Alice is the return data here. And we want to make sure that it did actually call our API client get user data with, in this case, it was the ID 1. Okay, let me quickly show you running the test. So we can say Pytest, and then this is test_service.py, and you see that it passes and we didn't get any errors. Okay, so that's mocking essentially a dependency of one of the functions that you're using, which is something that's quite common to do when you are testing code. Okay, so lastly, I want to give you a bit of a bonus here and show you how you actually test an API. So in this case, we have something like a Flask API, and this will differ depending on the type of module that you're using. But obviously, if you're using like Fast API or Django or Flask, they all have their own kind of testing built in or ways to perform testing. But I just wanted to show you how it might work with something like Flask, so you get an idea, because this is really more what you're going to be testing in Python, right? Real frameworks, real API endpoints, things that actually do require to be tested, not typically super simple functions, although yes, sometimes you do that as well. So in this case, I set up a Flask API. You can see it's simulating users. So adding a user, getting a user, etc. Okay, and we just have two endpoints, get user and add user. Now, if I want to test this, this is what I would do. I can set up a fixture called client. This client configures my app, which I've imported from the Flask app here, to be testing equals true. This is important because this allows you to actually get some more output from the API itself. Then what I do is I create a test client and I yield that within this with statement. Okay, so now anytime I use client, which is one of my fixtures here, it creates a new test client for me and allows me to test the API's functioning. So I have my test add user, I send a response, so I say client.post to /users, and then I pass this as the JSON, and this is what you can do, right? This is just how it works for Flask. Then I check the status code and the JSON and make sure that I'm getting the correct output. That's what I'm looking for. If I wanted to, for example, mock the user's database, I could. And then if I mock the user's database, I could then check in here to make sure that that mock was actually called and that I did add the correct value into the database. But that's getting a bit beyond what we need to do here. Same thing for getting a user. I send a post request. I then send a get request, and I make sure that this gave me the correct result. Try to retrieve a non-existing user. Same thing, make sure that we get the error. Hopefully you guys get the idea. I just wanted to quickly kind of show you how this would work in a Python framework. All right, so with that example shown, that is going to wrap up this video. Obviously, there's a lot more stuff that I could show you in Pytest. The documentation is pretty good, so I do recommend checking it out. But this was meant to be a quick introduction and overview of all of the important concepts, and hopefully this was able to get you up and running with Pytest. Now you understand kind of what a unit test is, how to write it, and some of the different features that are important to use when you get into more advanced testing. If you want more videos on this topic, definitely let me know. I look forward to seeing you in another video.